Hello and welcome to another video. So a couple days ago, my friend posted this on her Instagram, and she asked the following question: what color is my dress? And so basically, I decided to try and figure out what color her dress was, and how I did it was by using math. So I'm gonna show you today how to find out her dress color using math. Now the way we're going to do this is via something called the Euler Method. Now actually, when I did it a couple of days ago, when she actually posted it at that time I actually used Newton's method. But it turns out that Newton's method had some flaws in it. So I decided that I realized that the Euler method just works better in this case. Now how the Euler method works is that, so say you had a function here, we look at the graph here, we have a y of some xn equals yn with this function, and we have all these. So it's basically like solving a differential equation. So we get some like y prime of x, first derivative yx, equals f of xy, f is just some function, and this is our little differential equation here, and we get the y at some initial point x0, so y of x0, that's y0, and basically it's basically like an reiteration, so it's like a formula where we keep utilizing the technique, so it's like you can think of it as like an algorithm or whatever you want to think of it as, but basically it states that. So eventually we get to some point here, and that point is going to be our approximation of some value for our, and that's like a solution for differential equation kind of in a way. So like we have yn plus 1 equals yn plus h, which is our step size here. Yn plus 1, yn, those are just the y values evaluated at xn plus 1, xn. So, but with this h, and this h is the step size. So you can see we have x0, x1, x2. So we have x0 from x0 to x1, that's h. From x1 to x2, that's h. So that's our step size. And we then multiply it by our derivative here, I guess, evaluated at xn. These two really are this. So now we're gonna try and utilize this. So what I'm gonna do is I'm gonna set up a differential equation. So we're gonna have some, let's say color. So let's say we had some c prime of t. Now you're probably wondering why I picked these. So these variables. So c is, we're gonna say we have some function c, which stands for color, and we input something, and if we input this t, then we get out a c here, and basically this will tell us what is the color of the thing that we're inputting into our function. So I'm gonna have the derivative of this then. This is gonna be equal to some, I'm gonna use big F here, of tc. And now that we have our differential equation set up, we're now gonna assign a value, our x0 value in this case, or in this case it'll be t0. Well, so I'm gonna actually assign some value. We're gonna have c of, well, let's take a look, okay? So we need like a starting point, and if we look at this, we can see that my friend is sitting on some seats. So we'll use that as our starting point, our t0, so seats. And if we look at what color the seats are, we clearly see that they are green. The seats are green. So this is equal to green. And so now we have this, what we're trying to find. So let me write what we're trying to find. Remember, we're trying to find C of her dress, of a dress color. So we have a dress right here, our dress. So we're gonna try and find that. So we're gonna basically utilize the Euler method to do this. So let's begin. So basically, we have this right now here, and first of all, we need to see what we have here. Well, this is our C0, and this is our T. So look, our T0 right here, our initial T is the seats. I'll just write this initial thing we have here. the seat. And this right here of this, that's just C0, so that's green. Now we need to pick a step size. So the step size H, the step size should be something, you should try and get H to be quite small, because the smaller H is, the more accurate our approximation would be. So maybe pick a number between 0 and 1. For me, I'm going to pick 0.069. That's our H value. It's going to be pretty accurate, our approximation possibly, because this is indeed a small value between 1 and 0, and it's a bit closer. It's definitely a lot closer to 0. So that's our step size. And now that we have everything, we can just plug it all in. So we get that C1. Now if we look back at the formula, it's equal, that'll be y, so yn plus 1, that's C1. So that means that we have the before it, which is C0. So that's C0 plus our H and multiply by, if we look back at this is our little thing here, and that's what our derivative is equal to. We had this differential equation, and now we're plugging that in. So in this case, we have FDC. So F, but this needs to be yeah. So we have to establish T0, C0, but we know what our values are because we stated them right here. So let's plug those in. So we get them C1, that's C0, which is green. That's the wrong color. Green plus actually I'm thinking maybe it's best that I just do, I think just G for green. I think that'll be better. Yeah, that'll be a better yeah. It'll be more easier to see that way, I think, yeah. So we'll use our green G, alright, for green from now on. Okay, so anyways, we have G plus the H step size, which is 0.069, multiplied by, now, okay, so we have F and T0, we know that's the seats, and that's green. Green right here. You can see right there. And so now let's continue. So this is all equal to, this right here is the green plus 0.069. Now keep in mind this though, this right here, that's actually just C prime C. So that's the derivative right here. We saw it right here, right? C prime, yeah. So it's just, yeah. So now we need to compute this here, and we have this derivative evaluated. So we have the derivative of C of t evaluated at the seats. Now this is a bit difficult to compute, but I'm going to utilize them to help us a bit. So what we're going to do to compute that derivative is utilizing the definition. Should I write it right here? I feel like I should write it right here, right? Like right here, yeah. So I'm gonna pull this to the side a bit. So definition of a derivative. So how do we define a derivative? Well, there are many ways to do this, but there's actually a nice little way here. It's a nice little, we're gonna use a limit to define derivative. So how do we do this? Well, let's say you had, let's say you had a derivative of y of x, okay? So how do we evaluate this? Well, this is just the limit as we have some small change in x. Hold on, I need to draw this better. A small change in x, we'll call that delta x. As that's, we're going to take a limit as delta x approaches 0 of y of x plus the small change delta x plus delta x minus y of x, and all of that is divided by our delta x. And so now we can utilize this definition So we go back here, let's plug it in, shall we? So let's see, that's green plus 0.069, and we multiply it by, okay, I'm actually gonna move it. Should I move? Okay, I'm gonna see. I think I have enough space. Let me check. Multiply the limit as delta. Now it's not x here though. Remember, it's not x. It's t. So it's actually our change in the t value, the t, and as that approaches 0 of, so c of our x, which is our seats, plus this small change in the t, delta t, minus c of seats, all of that divided by delta t. Okay, so they have space here. Hold on, I'm just like do this a bit. Just you know, I'm gonna box it in a bit. You know, we have a nice little box here. Box. Yeah, nice little box. Definition of derivative. Okay. Anyways, back to here. Let's continue computing. Alright. So this is green plus 0.069. 69. Now this limit right here, it's a bit difficult to actually compute. But what we can do is we can just plug in some really small value for delta t that's very close to 0. And we'll see what happens. So let's just plug that small value in for now. So we're gonna have c of seats, and let our small value be somewhere very close to 0. So let's say 0.01. That's pretty close to 0. And minus c of seats. And we divide that by delta t, which is 0.01. Okay, let's figure this out. Seats plus 0.001. Add this number to the seats don't really change the seats that much. You know, I mean, if you add a number to like some, it doesn't really like change it that much. So actually, this is just c of seats. So let me just write this down. So we got green plus 0.069. So this right here is just c of seats actually, believe it or not. Because you're just adding a number to seats, but what does that do? What does adding a number to seats do? Doesn't really do much, right? So, and this is just 0.001. And so basically what happens here is this right here is how just 0. This is just this right here is just 0. And we know that it's 0. So this right here is 0. And we know that 0 divided by 0.01. So I'm just write this down. So we know the top, okay. Wrong color. It's green. Okay. 0.069. We know the top is just 0 and the bottom is 0.001. And we know that 0 divided by anything. Well, this is just 0. Yeah, this is just 0. And we know that 0 and we have multiplied by 0.069. But this all is just all of this. All of this is just it's just 0. So yeah, all of this is just 0. Okay, so actually I'm gonna all of this. Yeah, look, all of this. All this green plus all of this, that's just 0. I'll put in red. 0. And we know 0 plus anything, that's just 0. Just not 0. That's the thing. So like green plus anything plus 0 would just be that thing. So this is green plus 0, we get green. And what was green? C1. C1 was green. Okay. So now we have C1 here. Okay, and now we want to continue iterating this until we get our approximation. So now I'm gonna try and do C2. But before we do C2, we actually need our T1. That's important. Now, what's our T1 though? Well, that's just our... The thing about the T1 is that that's just the original, and we add our step size. And our T0 was just the seats, and our step size was 0.069. But adding 0.069 to the seats, once again, doesn't really change it that much. You're just adding a number to seats. What does that do? Your seats. And so C2, we plug it in. So, you know, formula, we got G green plus 0.069. My handwriting is terrible. Of F of seats green. But now this, what's this? This, and we all know what this is. This is just right over here. This is just all of this is the same as C1. And C1 we know is green. And you can by now see that if we continue iterating the pattern, like we continue doing this for a while, we eventually reach what we wanted. C dress or zero dress. My friend's dress color. And that's just green. So therefore, the color of my friend's dress is green. Okay, now we just box in our answer. And that's our final answer. The color of my friend's dress is green. And in case, and I know there's gonna be some people that are gonna doubt me, so in case of that, I'm gonna show you, okay? In case you want proof, yes. I asked my friend, yes, it's actually green. So yeah, color of my friend's dress is green. Thank you very much for watching. I like elephants. And yeah, goodbye.